Hello, ladies and gentlemen. Today we're going to take a look at two very important ideas in geometry, midpoint and distance. These are two key concepts that come up over and over throughout the year, and these are two big formulas that you need to make sure you understand and get in your notes. So our learning today is going to be centered around the idea of midpoint and distance. So can you use your understanding of midpoint and bisect to solve problems? And can you identify the formulas and use the midpoint and distance formulas accurately? So a few key words that I need to make sure you have in your notes. First of all, we're talking about midpoints today. And the midpoint of a segment is the point that divides the segment into two congruent smaller segments. So the midpoint is just what you think it is. It's the point in the middle. It makes two equal halves on either side. A bisector is a point, a ray, a line, a segment, or plane that cuts something else into two equal parts. So you're going to hear that word bisect a lot. Again, the prefix bi meaning two, so we're talking about bisecting or cutting into two equal parts. And oftentimes you'll hear the word segment bisector, angle bisector. A midpoint or a segment bisector will always bisect a segment. So the first example I need to make sure you have in your notes is this one. This one brings in some algebra into our geometry understanding here, and it says point M is the midpoint of segment VW. We need to find the length of segment VM. So for this, we're going to need to understand that M is the midpoint, and midpoints divide segments into two equal segments or two congruent segments. Right here, I have these little slash marks to indicate that those two segments are in fact congruent. And if they're congruent, that means that their length is equal. So the 4x minus 1 expression isn't exactly a number that we would add over there to the 3x plus 3, but we would understand that those two segments are in fact equal to each other. So that means that the 4x minus 1 equals 3x plus 3. Those are the lengths, and the lengths are equal. So now if we use our algebra skills to solve, we'd have 4x minus 3x is x minus 1 equals 3, so x would be 4. And if we know that x value, guys, then we can go ahead and find the length of VM, which is what the question was asking us to do, find the length of segment VM, by plugging that x value in on that segment. So 4 times x minus 1, if we plug in the x value of 4, we'd have 4 times 4 minus 1, we'd have 16 minus 1, which gives me a value of 15. So segment VM has a length of 15. That means I would write VM equals 15. Notice I didn't put the little segment bar above it because we're not talking about the segment itself, we're talking about the length of that segment. So VM, that segment has a length of 15. Okay, so that's how the algebra sort of comes back into this. That last example, you had the midpoint. What if you're asked to find the midpoint? What if you have 2 points like this on a coordinate plane and you need to find the middle? Well, to do that, we're going to use a formula, the midpoint formula. And I'll show you where this formula comes from, but it's like we're finding the average. You found averages before, the mean, if you will, by adding together the data and dividing by how many numbers you had. Your average test grades, add all of your tests together and divide by however many tests you took. The midpoint formula works in the same way. We're trying to find that average or find that middle. The midpoint formula says if you have 2 points, A and B, on a coordinate plane, the midpoint will have the coordinates given here by this formula. x1 plus x2 divided by 2, y1 plus y2 divided by 2. We're dividing by 2 because we're trying to find the midpoint between 2 points. And we're adding those points together and dividing by 2, just like you would do if you have an average. So let's see what this one looks like in an example. Here are 2 endpoints. The endpoints of segment RS, that little segment bar should be over here, R is located at 1, -3, and S is at 4, 2. Find the coordinates of the midpoint. Write this little example in your notes. And we're going to use the fact that midpoint equals x1 plus x2, oops, there we go, divided by 2, and then y1 plus y2 divided by 2. So we need to plug in the x and y coordinates into this formula. Now, one way to do that is to remember, go back through your points here. This is an x value, this is a y value, this is an x value, this is a y value. The fact that R has is the first point that's listed means that I just label them with 1s, and the other guy gets 2s because he's the second point listed. But it won't really matter because we're adding them together. In addition, the order does not matter. Okay, so x1 plus x2 is what I'm going to first plug in. So my x1 is a 1 plus x2 is a 4, and then I'm going to divide by 2. y1 was a 1 plus y2 divide by 2. And if I go ahead and calculate this, or actually figure out the math here, 1 plus 4 is 5, so this is 5 halves. And this is negative 1 over 2. And if you want to think about this as a location on a graph in approximate or in decimal form here, when we go to graph, we usually have to try to approximate where these are. This is 2.5, and this is negative 0.5. So if we look at where those points started, and we were trying to find the midpoint in between them, if I show you a little graph here, that's where these 2 points were located, R and S. And we tried to find the coordinates of this midpoint. We did it without even making a graph, because sometimes making the graph takes longer than it would just to find that midpoint. But we found a location that that fits this description. Over 2.5, down a half. Yeah, that's the midpoint between those 2 points. So the midpoint formula helps us find those midpoints. But it can also help us find endpoints. So this third example I need you to get in your notes. The midpoint of JK, and my segment bar did not show up there. JK is M midpoint 2, 1. One endpoint is 1, 4. Find the coordinates of the other endpoint K. So in this case, we know the midpoint. We know one endpoint. So we know x1, y1. But we don't know the other endpoint. We're looking for the other endpoint that wasn't given to us. And the midpoint formula can still help us figure this one out as well. So I'm just going to write the midpoint formula here so you can see where we're plugging in those numbers. And we're going to use our algebra skills to help us solve this. Let's plug in what we know. We know the midpoint, or M, is at 2, 1. And then we know x1 is 1, but we don't know x2. So I'm just going to leave him as a regular x here. Divide by 2. And we know y1 is 4. That's a 4 here. And then y2 I don't know, so I'm just going to leave him as a y divided by 2. And so now I have to use my algebra skills to help us solve this. Now, what I know is that the x part of this point needs to work out to make a 2. That means all this stuff right here needs to equal 2 when I solve for the x. So I'm going to go ahead and take that stuff and set up a little equation here. 2 is the x-coordinate equals the algebraic expression for the x-coordinate. And now we'll go ahead and solve for x. I'm going to multiply by 2, multiply by 2. So I have 4 equals 1 plus x minus the 1 here. X is 3. So I now know the x part of the point is 3. I need to find the y. Well, using the same idea, the y part is a 1 when it all works out. So that means this part needs to work out to make a 1. So again, I'm going to set up a little mini equation here. 1 equals 4 plus y over 2. We'll multiply by 2 again. 2 equals 4 plus y. So then if I subtract the 4, y would be negative 2. So right here, negative 2. So now I have found the other endpoint, and I would say endpoint K here, that's his location. He's at 3, negative 2. So the midpoint formula helps us find the midpoint. It can also help us find an endpoint. The last formula we need to get in your notes is the distance formula. And again, I'll show you where this one comes from as well in class. But the distance formula helps you find a length. Not the middle, but how long an actual segment is. So again, we're talking about being on a coordinate plane. So we'll have x1, y1, x2, y2. And if we need to find the distance or the length between them, let's say we need to know if they're congruent or not, we would use this distance formula. We have a big square root there, big radical sign, and we have x2 minus y1 quantity squared, y2 minus y1 quantity squared. You may have used this formula before. And we'll go ahead and do one example. So here's the example we need to do. We're going to find the distance between these 2 points. We're going to write the approximate length of RS. This should be segment RS again. Those segment bars don't want to show up. With endpoints R and at S. So we need to find that length of segment RS. So we're going to use that distance formula to make that happen. So distance equals square root x2 minus x1 squared plus y2 minus y1 squared. So if I was going to start to plug in numbers here, again, some people find it helpful to label those coordinates. So this is x, y, x, y. This is x and y from the first point. This is x and y from the second point. And now they all have labels, and we can just plug them in where they go in this formula. So x from the second point, 4, minus x from the first point, 2 squared. And then plus sign, y2 is negative 1, minus y1 is 3 squared. And now using your order of operations, we always start in the parentheses here. We're going to do this part first. So 4 minus 2 is 2 squared, and this is all underneath a square root, plus negative 4 squared. And now once you've done parentheses, then you would move to exponents. So we have the square root of 4, 2 squared is 4, plus negative 4 squared is negative 4 times negative 4, positive 16. So if I simplify now and say 4 plus 16 is 20, I have the square root of 20. Now you can at this point go into your calculator and approximate this decimal value if you would like. At this point of the year, that's acceptable. You may also decide to simplify the square root. I'm assuming you know how to type that in your calculator and to give the decimal value, but I'll refresh your memory if you need to remember how to simplify the square root if that's something you would like to do. So the square root of 20, I would break that apart using 2 smaller radicals, 2 smaller square roots, and one of them needs to be a perfect square. So 4 is a perfect square, so I'm going to break this 20 apart using 4 times 5. Square root of 4 times square root of 5 is the square root of 20. Now I do that because the square root of 4 is just 2. So this simplifies to make 2 square roots of 5. So 2 square roots of 5 would be the length from R to S. Okay? And again, if you want to write the decimal value, that's fine at this point in the year. So we've taken a look at midpoint and distance. I hope you've taken good notes, and I want to thank you for taking good notes. See you when I see you.